Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In this session, we will discuss LTS MPL Physics Weekend Test 19. So let's start with question number 1. An equiconvex lens forms a real image of an object which is twice the size of the object. The magnification is -2. The distance of the object from the lens is -24 centimeter. The wavelength of the light inside the lens, is 2 by 3 times the wavelength in air. The radius of each curved surface of the lens is. So magnification for a lens is V upon U and V will be -2U. So it will be -2 times U is -24. So it will be 48 centimeter, right? So using lens formula, we can write 1 upon V minus 1 upon U is equals to 1 upon F. 1 upon V will be 1 upon 48 minus 1 upon U is -24 is equals to 1 upon F. After solving this one, you will get focal length as 16 centimeter. Now apply lens maker's formula. So in this case, 1 upon F is 1 upon 16 is equals to mu minus 1, which is refractive index of the lens into 1 upon R1 minus 1 upon R2. Okay? But we know that refractive index mu is C upon V, which is frequency into lambda in air divided by frequency into lambda in glass. So frequency cancel. So over here lambda in glass or lens is 2 by 3 times lambda A. So this will be lambda A by 2 by 3 times lambda A. Lambda A cancel. So it will be 3 by 2. So mu is 3 by 2 over here, right? So let's put this value here. So it is 1 upon 16 is equals to 3 by 2 minus 1 is 1 by 2 into 1 upon R1. So this is equiconvex lens, so R1 will be positive. So 1 upon R minus 1 upon minus R, right? So this will be 1 upon 16 is equals to 2 upon 2R. So R will be 16 centimeter, which is option 1. Question number 2. A converging lens is used to form an image on a screen. When the upper half of the lens is covered by an opaque screen, so what will happen? Image will be completely formed, but the intensity of the image will decrease, right? Because of less number of rays. So over here, correct answer is option 4. Question number 3. A convex lens of focal length 25 centimeter and a concave lens, so this is F1, this is F2, of focal length 10 centimeter are placed coaxially distance x apart. If a parallel beam of light falling on the convex lens leaves the concave lens as a parallel beam, the value of x must be. So this is convex lens, this is concave lens, coaxial, right, and parallel beam of light which is coming from some infinite object will try to converge at the focus like this, but this will make them again parallel. So they are trying to converge over here, right? So this must be the focal length, which is 25 centimeter, and this must be the focus point for concave lens, which is 10 centimeter. So the separation between these two lenses should be what? 25 minus 10, that is 15 centimeter, which is option 4. Question number 4. The real image which is exactly equal to the size of an object is to be obtained on a screen with the help of a convex lens of focal length 15 centimeter. So when you place image object as 2f, then image will be at 2f, right, over here. So if object is placed at 30 centimeter, image will be at 30 centimeter, right, and object size and image size will be same, right. So in this case, what should be the distance between object and screen? So what is the distance between object and image? 30 and 30, 60 centimeter, which is option 4. Question number 5, the refractive index of a prism for a monochromatic wave is √2 and the refracting angle is 60 degree. For minimum deviation, the angle of incidence will be, so for minimum deviation mu will be sin I divided by sin A by 2, right. So sin I will be mu times sin A by 2, which is √2 into sin 60 by 2, which is 30 degree. So this will be 1 by √2. So I will be 45 degree. Question number 6. A ray of light passes through an equilateral glass prism in such a manner that the angle of incidence is equal to angle of emergence. Okay, and is equal to 3 by 4 times the angle of prism. So this is equilateral glass prism. So A will be 60 degree, right. So this will be 3 by 4 into 60, which is 45 degree. Okay. The angle of deviation is, so in this case 2I is equals to A plus delta M, right. So I is 45, so 2I will be 90 is equals to A 60 plus delta M. So delta M will be 30 degree. So correct answer is option 4. Question number 7. A thin prism P1 with angle 6 degree and made from a glass of refractive index 1.54 is combined with another thin prism P2 of refractive index 1.72 to produce dispersion without deviation. The angle of prism P2 will be, so we are producing dispersion without deviation, that means A dash upon A should be mu y dash minus 1 upon mu y minus 1. A dash is unknown, A is given as 6, mu y dash over here is 1.72 minus 1 divided by mu y is 1.54 minus 1. So this is 0.72 divided by 0.54, right. So after solving this one, you will get option 2. Question number 8. Out of the following, dispersive power of a prism depends upon, it depends on material of the prism. So correct answer is option 4. Question number 9. For a material, the refractive indices for red, violet and yellow color light are respectively this. The dispersive power of the material is, so omega is mu v minus mu r divided by mu y minus 1. So this will be, for violet color it is 1.64 minus, for red it is 1.52 divided by yellow it is 1.60 minus 1. After solving this one, you will get dispersive power as 0.2. Next is question number 10. A convex lens of focal length 50 cm and a concave lens of focal length 100 cm are separated by a distance of 10 cm. What is the power of the combination? So power is given as 1 upon F1 plus 1 upon F2 minus x upon F1 F2. So it will be 1 upon F1, this is convex lens, so it will be plus 0.5 plus 1 upon F2. Second one is concave lens, so it will be minus 1 only, minus x is 0.1 divided by F1 is 0.5 into F2 is minus 1. So after solving this one, you will get power as 1.2 diopter. Question number 11. Focal length of a convex lens will be maximum for, focal length of a convex lens is maximum for red light, okay, because mu is A plus B upon lambda square, okay. So over here mu will be minimum for red, because wavelength of red is maximum, right. So over here mu will be minimum for red, right. So 1 upon F is mu minus 1 into 1 upon R1 minus 1 upon R2. So if mu is minimum, then 1 upon F will be minimum and F will be what? Maximum, right. Question number 12. A concave lens of focal length F produces an image 1 by n times, then that of the size of the object. The distance of the object from the lenses. So this is a concave lens, and concave lens can produce only virtual images. So magnification will be positive, which is V upon U. So V will be U upon N. Okay. So U will be minus U, and focal length of the concave lens is minus F, and V is plus U upon minus u upon n because it is virtual, right? Okay. This is concave lens, so image will be virtual over here, right? Okay. So after putting all these values, if you write 1 upon v minus 1 upon u is equals to 1 upon f, it will be 1 upon minus u upon n minus of minus u is equals to 1 upon minus f. So it will be n minus 1 minus n plus 1 upon u is equals to minus 1 upon f. So if you multiply minus on both the sides, it will be n minus 1 upon u is equals to 1 upon f. So f is equals to u is equals to n minus 1 into f, which is option 4. Question number 13, the correct curve between potential and distance d near PN junction is. So basically majority of the current is because of the diffusion of majority charge carrier across the junction. So from p type holes will move, and from n type electrons will move towards p type, right? So in this case the potential across towards n type will be positive and towards p type it will be negative, right? So correct answer is option 4. Question number 14, in a full wave rectifier circuit operating at 50 Hz means frequency, the fundamental frequency in the ripple would be. So in this case T1 will be T by 2, which is equal to 1 upon 50 into 2, which is 1 upon 100. So frequency will be 1 upon time period, which is 100 Hz. Next is question number 15, the potential difference between A and B. So this diode is forward, right? So it will offer 0 resistance. So effective resistance of 10 kilo ohm and 10 kilo ohm in parallel will be 5 kilo ohm, right? So effective resistance will be 10 plus 5, 15 kilo ohm. Now the current through this circuit will be V upon 15 kilo, which is 30 upon 15 into 10 power minus 3, which is 2 milliampere, right? This will be the current. Now potential difference across, this will be potential difference across the combination of this two, that is 5 kilo ohm. So it will be V is equals to I into R, 5 into 10 power 3 into 2 into 10 power minus 3, which is equal to 10 volt. So correct answer is option 3. Question number 16, the potential barrier of 0.5 volt exists across PN junction. If the depletion region is this, the intensity of the electric field will be. So A is equals to V upon D. So it will be 0.5 divided by D is 5 into 10 power minus 7. So it will be 10 power 6 volt per meter, which is option 1. Question number 17. An electric field is applied to a semiconductor. Let the number of charge carriers be n and the average drift speed be v. If the temperature is increased, so we know that I is equals to Ne into Ve plus Nh into Vh. Okay. So using this, if you increase the temperature, n will increase but V will decrease, right? So correct answer is option 2. Question number 18, a full wave PN diode rectifier uses a load resistance this much. No filter is used. The forward bias resistance of the diode is this. The efficiency of the rectifier is. So in this case, efficiency of the rectifier is given as this much, right? So this will be 0.812 into load is 1500 divided by 1500 plus 10. So it is 1510 into 100%, right? So it will be approximately 80.6%. Next is question number 19. Pure Si at 500 Kelvin has equal number of electron and hole concentrations at 1.5 into 10 power 16 meter inverse cube. Doping by indium increases NH to this. The doped semiconductor is off. So over here NH into Ne is equals to Ni square. So Ne will be Ni square by Nh. Put the value of Ni as this one and Nh to this one, you will get Ne, and that will be 5 into 10 power 9 per meter cube, and the doped semiconductor over here is of p type, right? So correct answer is option 1. Question number 20, the energy of a photon of sodium light is this one, and we need to find the minimum energy required to create an electron hole pair. So minimum energy required is Hc by lambda. So in this case, after putting all these values, you will get answer as 2.1 electron volt. Question number 21, when a white light passes through a hollow prism, then there will be no dispersion and no deviation. Question number 22, a ground glass prism with refractive angle 6 degree is to be achromatized for red and blue light with a flint glass prism. Angle of the flint glass prism should be. So in 22, let's apply this one. Mu r minus mu b into A is equals to mu r dash minus mu b dash into A dash. Right, so mu r is 1.513 minus mu b is 1.523. A is 6 is equals to mu r dash is 1.645 minus mu b dash is 1.665 into A dash. So after solving this one, you will get angle of prism as 3 degree. Question number 23. The plano concave lens is made of glass of refractive index 1.5 and the radius of curvature of the curved face is 50 centimeter. The power of the lens is. So power is 1 upon focal length and that is equals to, in this case it is minus mu minus 1 upon r. This is concave lens, right? So this will be minus of 1.5 minus 1 divided by r. Radius of curvature of the curved face is 50 centimeter, right? So this will be 0.5. So this is minus of 0.5 divided by 0.5, which is minus 1 diopter. So correct answer is option 1. Question number 24. When a glass prism of refractive angle 60 degrees is immersed in a liquid, its angle of minimum deviation is 30 degree. The critical angle of glass with respect to liquid medium is. So we know that mu is equals to sine A plus delta m by 2 divided by sine of A by 2, right? So A is 60 and delta m is 30. So 60 plus 30, 90. 90 by 2 is 45. Sine 45 is 1 by root 2 divided by sine A by 2. Sine 30, which is 1 by 2. So it will be 1 by root 2. Right, root 2. Okay, it will be root 2, right? So mu is root 2 and we know that sine C is 1 upon mu. So it is 1 upon root 2. So C will be 45 degree. Question number 25. The radius of curvature of the convex face of a plano-convex lens is this. What is the focal length? So 1 upon f is mu minus 1 into r divided by r. So mu is 0.5 divided by r is 12. So this will be 120 divided by 5, that will be focal length, which is equal to 24 centimeter. Correct option is 3. Question number 26. An eye specialist prescribes spectacles having a combination of convex lens of focal length this and concave lens of focal length this. Okay, so power of the combination will be 1 upon f1 plus 1 upon f2. So it will be 1 upon 0.4 minus 1 upon 0.25. I am putting this with negative sign because it is of concave lens. So after solving this one, you will get your answer as minus 1.5 diopter. Question number 27. We have a ray PQ as shown in the figure. Okay. Suffers minimum deviation in equilateral prism A. Okay. Two more identical prisms B and C are of the same material as A are now placed in contact as shown in the figure. If prism A produces minimum deviation delta m, the deviation produced by the combination of prism ABC will be. So these are of the same material, right, and identical prism, right. So in this case there will be no deviation. So final deviation produced by C will be same as that of the A. Okay. So correct answer will be option 3. Question number 28. We have two wires A and B of same material and of the same length are stretched between two fixed supports. Wire A is thicker than B. If their initial temperatures and tensions are same, then due to increase in temperature. So we know that F is equals to Y alpha delta T into A, right. So you can see that F is directly proportional to A. So TA decreases more than TB. So correct answer will be option 2. Question number 29, a stress of this is required for breaking a material. If the density is this, then what should be the maximum length which can be hanged so that it is at the point of breaking by its own weight, right? So breaking stress is force upon area, which is equal to mg. So mass is volume into density into g divided by area. Volume is area of cross section into length, ठीक है, into rho g divided by area, ठीक है, is equals to breaking stress, which is equal to 10 power 6. So L will be 10 power 6 divided by rho g. Rho is 3 into 10 power 3. G is 9.8. So after solving this one, we'll get correct answer as 34 meter. Question number 30. The Poisson's ratio for the material of a wire is this. When the force is applied to the wire, the strain is this. The percentage change in the radius of the wire is. So Poisson's ratio is minus R, delta R divided by delta L divided by L. Right. So minus delta R divided by R is sigma into delta L divided by L, and if you multiply it by 100, you will get percentage change, right? So this will be 0.4 into 1 by 100 into 100, so it is 0.4%, which is option 3. Question number 31. A 2 cm cube of same substance has its upper face displaced by 15 cm by a tangential force of this. Fixing its lower face, calculate the rigidity modulus of the substance. So it is force upon area divided by delta x upon L. Force is 0.3 divided by area of cross section. It is a cube of 2 cm side, so it will be 2 into 10 power minus 2 whole square divided by delta x is 0.15 divided by L is 0.2. So after solving this one, you will get modulus of rigidity as 10 power 4 Newton per meter square. Question number 32. When a block of mass m is suspended by a long length L, long wire of length L, the length of the wire becomes L plus delta L, L plus small l. The elastic potential energy stored in the extended wire is, so it is half F delta L, so it is half mg into extension in the wire is L. So correct answer is option 4. Question number 33. The Young's modulus of brass and steel are this and this respectively. We have same length of the wire and are extended by the same amount under the same force. Then radii of brass and steel wires are in the RB and RS respectively. Then which of the following option is correct? Right. So in this case, we know that Young's modulus is FL upon A delta L. So A is FL upon Y delta L. Now FL delta L all are same, so area of cross section is inversely proportional to Young's modulus. So pi r square is inversely proportional to Young's modulus, so R is inversely proportional to under root of Young's modulus. So you can write RB upon RS is equals to under root of YS divided by YB. So after putting the value of YS and YB, you will get your correct answer as option 2. Question number 34. A body subjected to strain a number of times does not obey Hooke's law due to elastic fatigue. So 3. Question number 35. When a metal sphere is suspended at the end of a metal wire, its extension is 0.4 millimeter. If another metal sphere of the same material with its radius half as the previous is suspended, then extension would be, okay. So basically we need to find the extension over here. So let's find it, guys. We have a metal sphere, its radius is r. So its mass is density into volume, which is density into 4 by 3 pi r cube, right? So we have Young's modulus as FL upon A delta L. So delta L will be FL divided by by A. So force is because of the mass of the sphere, so it is mg, so it is rho 4 by 3 pi r cube into g into L divided by Ya. So you can see that delta L is directly proportional to r cube, so delta L1 divided by delta L2 is equals to r1 cube divided by r2 cube, right? So if you put the values, R1 is R, R2 is R1 by 2, R by 2, delta L1 is 0.4 millimeter, you will get the value of delta 2 which is equal to 0.05 millimeter. Question number 36, we have ABC which is right angled prism like this, and with other angles as 60 degree and 30 degree, refractive index of the prism is 1.5, okay. AB has thin layer of liquid on it as shown in the figure. Light falls normally on the face AC. For total internal reflections, maximum refractive index of the liquid is. So over here, refractive index of the liquid we need to find. So in this case, we can write refractive index of the liquid is equal to refractive index of glass into sine 60 degree, which is root 3 by 2. Right. So in this case, I think it will be 1.5 into root 3 by 2. So correct answer will be approximately 1.3. I hope this is clear, right? So next is question number 37. We have an object which is placed at a distance of 12 centimeter, and we have a convex lens of focal length 20 centimeter. And a plane mirror are arranged like this. How far behind the mirror is the second image formed? Okay. So in this case, let's find the location of the image by lens first. So it is 1 upon V minus 1 upon U is equals to 1 upon F. So 1 upon V will be 1 upon 20 minus 1 upon 12. So this will be 60, this is 3 minus 5 which is equals to minus 2 upon 60. So V will be minus 30 centimeter. V will be minus 30 centimeter. Matlab image formed by the lens over here is at a distance of 30 centimeter from the lens, and that too on the same side of the object. So this image will behave like an object for the mirror. So total distance of the object and mirror will be, now it is 30 plus 10, 40. So mirror will form image at the same distance behind it, right? So at a 40 centimeter there will be another image. So correct answer is option 3. Question number 38. What is the relation between the refractive indices over here? So there is no bending of light. Mu1 is equals to mu, right? Mu1 is equals to mu1, mu over here. So first is this one, and in this case this is the normal. So light should go like this, but it is bending towards the normal. That means light is traveling from rarer to denser medium. So mu2 is greater than mu. So correct answer is option 3. Question number 39. A plano-convex lens of curvature of 30 centimeter and refractive index this produces a real image of an object kept 90 centimeter from it. What is the magnitude of the magnification? We have plano-convex lens. So its focal length will be 1 upon f is mu minus 1, which is 0.5, into 1 upon r, which is 1 upon 30. So f will be 60 centimeter. Now we need to find the location of the image also. So 1 upon v minus 1 upon u is equals to 1 upon f. So 1 upon v will be 1 upon u minus 1 upon f minus 1 upon u over here. So this is this will be 180. So this is 1 upon 180, right? So v is 180 centimeter. Magnification will be v upon u, which is 180 divided by 90. So magnification will be 2. Next is question number 40. The image of the needle placed 45 centimeter from a lens is formed on a screen placed 90 centimeter on the other side of the lens. So we have lens and needle is here, and its image is at 90 centimeter. So 1 upon f is equals to 1 upon v, which is 1 upon 90 minus 1 upon u, which is minus 45. So this will be 90 and this will be 1 plus 2. So this is 3 upon 90 and it is 1 upon f. So f will be 30 centimeter. Now we are moving the needle away from the lens by 5 centimeter. So new distance of the object will be 50 centimeter. So 1 upon F is equal to 1 upon V minus 1 upon 50, which is minus minus plus. So 1 upon V will be 1 upon 30 minus 1 upon 50. So this will be 150. This is 5. This is minus 3. So this is 1 upon V. So V is 75 centimeter. So initial image is at 90 centimeter. Now it is at 75 centimeter. That means image is shifting towards the lens. And how much? By 15 centimeter. So correct answer is option 3. Question number 41. A point object is placed at the center of a glass sphere of radius 6 centimeter and refractive index 1.5. The distance of virtual image from the surface of the sphere is. So we have medium 1 as 1.5, mu1 as and mu2 as 1, and the distance of the virtual image from the surface of the sphere is. So we need to find V, and R is given as minus 6 centimeter over here. Right, so we can apply this expression. Mu2 minus mu1 upon R is equals to mu2 by V minus mu1 upon U. So mu2 is 1 minus 1.5 divided by minus 6 is equals to mu2 is 1 divided by V minus mu1 is 1.5 divided by U is again minus 6. Right, so this will be minus 0.5 divided by minus 6 is equals to 1 upon V plus 1 by 4. So this will be minus minus cancel. So this will be 1 by 12 minus 1 by 4 is equals to 1 by V. So this will be 12 and this will be 1 minus 3. So this is 1 by V. So V will be minus 6 centimeter over here, which is option 3. Question number 42. A spherical sphere of radii of curvature R separates air from glass. The center of the curvature is in the glass. Okay. A point object P is placed in air is found to have a real image Q in the glass. So it is like this. This is point object P, this is image Q, this is O, and PO is equals to OQ. Matlab, if V is plus X, then U is minus X. Okay. This is mu1 which is 1 and this is mu2 which is 1.5. Okay. We need to find the distance PO. So let's apply this equation, and we have a radius of curvature R which is positive in this case. So mu2 minus mu1, 1.5 minus 1.5 divided by R is equals to mu2 upon V, which is 1.5 divided by X minus mu1 upon U. So this will be 1 upon 2R is equals to 1.5 upon X plus 1 upon X. So this will be, after solving this one, you will find the value of X as 5R. Next is question number 43. A composite light consisting of red, green and blue colors is incident on face AB of a glass prism. The blue light is just totally internally reflected at face AC as shown in the figure. Okay. So blue light is performing TIR, and before that we have red and green light also. So we know that mu is equals to A plus B upon lambda square. Right, lambda is maximum for red, so mu will be minimum for red. So mu R is less than mu green is less than mu blue, and sin C is equals to 1 upon mu. So if mu is more, sin C will be less. So C will be less. Right. So critical angle will be less for blue than green, will be lesser for blue as compared to green and red. Right. So that is why blue is performing TIR, because its critical angle value is less as compared to red and green. So red and green, they will emerge out of this AC surface. Right. So correct answer is option 3. Next is question number 44. We have diode used in this circuit like this. The potential drop across this one is 0.5 volt and maximum power rating is 100 milliwatts. What should be the value of the resistor R connected in series with diode and obtaining maximum current? Okay. So let's find the resistance of the diode. So power is V square upon R. So resistance of the diode will be V square upon P, which is 0.5 ka whole square divided by 0.1. राइट. सो दिस विल बी, ये हो जाएगा 0.25 divided by 0.1. So this will be 2.5 ohm. So resistance of this one is 2.5 ohm. ठीक है. Now current in the circuit will be I is equals to V upon R, 0.5 divided by 2.5. तो ये हो जाएगा 2 ampere, right? And according to 2 ampere, let's find what is the total resistance offered, right? So it is V upon R is equals to 2. It will be 0.2, right? 0.2. So R will be 1.5 divided by 0.2. So this will be 7.5 ohm, right? So out of 7.5 ohm, this is 2.5 ohm. So this will be 5 ohm. So correct answer is option 1. Next is question number 45. We have a junction diode of internal resistance 20 ohm is used for half wave rectification. If the applied voltage has a peak value of 50 volt and the load resistance is this much, the DC value of current is, so IDC is Im upon pi. Im will be V0 divided by 800 plus 20, 820. So IDC will be 50 divided by 820 into pi. So after solving this one, the value of current will be 19.4 milliampere. Next is question number 46. We have prism is made of material of refractive index this. The angle of prism is A. If the angle of minimum deviation is equal to angle of the prism, matlab delta M is given as A. So we know that mu is equals to sine of A plus delta M by 2 divided by sine A by 2, right? So this will be sine 2A by 2. So you can write it as sine A, which is sine 2 sine A by 2 into cos A by 2, and that is equal divided by sine A by 2. Sine A by 2 will cancel this sine A by 2 over here, right? So mu is 2 cos A by 2. Mu is root 3. So root 3 is equals to 2 cos A by 2. So cos A by 2 is root 3 by 2. And it is root 3 by 2 when the angle is 30 degree. So A by 2 is 30 degree. So A will be 60 degree. So correct answer is option 3. Question number 47. We have a thin glass prism of refractive index this produces a deviation of 4 degree of a ray incident at a small angle. What will be the deviation of the same incident ray by the same prism if it is immersed in water of refractive index 4/3? ठीक है. Initial deviation delta is mu minus 1 into A. ठीक है. So this is 4 is equals to 1.5 minus 1.5 into A. Now new deviation is, let's say, delta dash, and this is mu of glass divided by mu of water, that is 4/3 minus 1 divided by A into A. Let's divide these two equations. A cancel. So after solving this one, you'll get the value of delta dash, that is 1 degree. Question number 48. A concave lens of glass refractive index 1.5 has both surfaces of the same radius of curvature R. On immersion of the medium of refractive index 1.75, it will behave as, ठीक है. So initially when it is in air, so concave lens है and its refractive index is this. So 1 upon focal length in air is mu minus 1, which is 1.5 minus 1 into first radius of curvature R1, and it will be negative. So it is minus 1 upon R minus 1 upon R. So this will be minus 0.25 into 2 upon R. Now 1 upon focal length in medium is 1.5 divided by 1.75 minus 1 into minus 2 upon R. ठीक है. So this is 1 upon FA. After solving this one, you'll get the value of new focal length, and that new focal length will be 3.5 R. ठीक है. New focal length will be 3.5 R, and it will behave like what? A convergent lens of focal length 3.5 R. Next is 49. We have rubber cord has cross sectional area this, and its initial length is this, and it's stretched by this much amount, and ठीक है. Taking the Young's modulus be this, what is the velocity of the stone? So we can say that half mv square is equals to half into Young's modulus into strain ka square into volume, right? So in this case, half m is 5 into 10 power minus 3 into v square is equals to half. Young's modulus is 5 into 10 power 8 into strain square, that is delta L upon L. So it is 5 upon 10 ka whole square into volume. Is area of cross section is 25 millimeter square. So this is 25 into 10 power minus 6 into length is 10 centimeter, which is 0.1. So after solving this one, you will get the value of velocity as 250 meter per second. Next is question number 50. We have a bar is subjected to equal and opposite forces as shown in the figure. ठीक है. We need to find the tensile stress on PQ. So tensile stress क्या हो जाएगा? Normal force divided by area, right? So over here normal force will be F cos theta and divided by area. This area is A, so this area will be A upon cos theta. So this will be A upon cos theta. So this is F upon A cos square theta, right? So correct answer is option 3.